Hey everyone, welcome back to Day 64, the most known use cases series where we talk about real world scenarios that demand clever encoding techniques and strategies to make modern systems work smoothly. If you have been following along, you already know that Base 64 plays a critical role in ensuring data integrity across diverse platforms. And today we are diving into our third use case, one that is especially relevant for real time applications and microservices communication. Modern messaging protocols like WebSockets, Apache Kafka, and RabbitMQ are the backbone of real time systems. They are fast, they are reliable, and language agnostic. But here's the catch: their most common configurations are optimized for text based payloads. That's great for JSON, XML, or text strings, but what happens when you need to send a binary file like a PDF or an image? That's where Base 64 steps in. It transforms binary data into a safe, text friendly format that the protocols can transmit without breaking a sweat. In this video, we will walk through a hands on demo using WebSockets and send a PDF between two clients encoded in Base 64, then decoded on the other side and verified for integrity. Now you might be wondering why WebSockets? Why not Kafka or RabbitMQ? They are powerful, they are scalable, and they are great for production systems. But they also come with setup overheads, routers, queues, deployment complexities, brokers. So WebSockets are perfect for this demo because they are lightweight, they are browser friendly and ideal for showcasing real-time bidirectional communication. Plus, they let us build a fully interactive experience without needing a heavyweight setup. So stick around, we will cover the encoding logic, the WebSocket setup, and the dynamic file transfer flow. By the end of the video, you will not only understand how Base 64 enables binary safe messaging, but also have a working demo you can adapt for your own projects. Alright, so before we jump into the code, let's take a moment to understand these key concepts behind the demo. If you're new to real-time messaging or WebSocket based systems, this will help you follow along with full confidence. Most of the web runs on HTTP protocol, the classic request and response model. The browser asks for something, the server replies, and the connection closes. Deal done. That's great for loading pages or submitting forms, but not so great when you need live updates or two-way communication. For things like real-time file transfer or instant sync, we need something more persistent. Developers have tried to work around HTTP's limitation using polling. In short, polling, the client keeps asking the server, like, hey, anything new? Any updates? Which wastes bandwidth and server resources as well. Long polling is a bit smarter, where the client asks once and waits until the server has something to say. It's better, but still relies on repeated reconnections and isn't really real time. So WebSockets solve this problem. They start as an HTTP request initially, but then upgrade to a persistent TCP connection. That means that both the client and the server can send data whenever they want. There is no need to wait for a request. It is full duplex, low latency, and perfect for our use case, which is sending binary files encoded as text. So why we use base 64 for binary transfer is that many messaging protocols, including WebSocket, STOMP, and even JSON are text based. See, don't handle raw binary data really well. That's where base 64 comes into play. It converts the binary files into safe readable text that can travel to these systems without getting corrupted. Yes, it adds about 33% of overhead, but it's worth it for reliability. Now let's talk about STOMP. STOMP is simple text-oriented messaging protocol. Think of it as a tiny standard that sits on top of our WebSocket connection and turns that raw socket into a lightweight message bus. Instead of sending arbitrary bytes and inventing your own rules, STOMP gives you frames like connect, send, and subscribe, so both the client and server speaks the same language. This is especially useful in Spring because Spring messaging maps STOMP frames directly to controller methods or endpoints. So you get readable messages, topic based routing, and an easy part to add broker backed durability later. For our demo, we will be using STOMP with SockJS, so browsers get fallback, and we will send base64 payloads inside STOMP send frames. So for this project, we need some couple of extra dependencies from over here. So first of all, I'm going to add WebSocket dependency for support. Then I'm going to add time leaf because we are going to have a small front end code as well. Nothing much, just HTML, CSS, and JavaScript. So as you can see, these are added. I'm going to copy these and I'm going to paste it in my pom.xml file. Okay, this is a good place. I'll just paste it. Okay. Also, I'm going to be needing a couple of more dependencies over here. First will be of sockjs and then of stomp. I'm going to do a quick maven reload. It will take a minute or two to actually load all these dependencies into our project. Until then, we'll be going to wait. And once this is resolved, create one package and call it as config. The heart of any Spring WebSocket application is the configuration. So we are starting with our WebSocket config class. You can see that it is annotated with @configuration, and I'm going to also annotate it with @enable WebSocket message broker. That second one is what actually turns on our powerful Stomp message brokering capabilities. And this class is going to actually implement the class WebSocket message broker configurer. And then I'm going to be generating some overridden methods for over here. First will be register stomp endpoints, and the second one will be configure socket transport. I also need one more method. I think it is going to be this configure manage message broker. So yeah, I've added these three methods. I'm going to remove this implementation. For now, I'm going to add my custom implementation. So first up is our register stomp endpoints. This is where the initial handshake happens. So I'm going to actually write down the steps that are needed for this in comments. So first is our WebSocket handshake, and we are going to allow all origins for now. And after that, we are going to enable sockjs. So I'm going to write down registry.add endpoint, and I'm going to add this endpoint and call it as /ws. And because I want this to work on a wide variety of browser, I am enabling sockjs that provides a neat fallback for older browsers that don't natively support web sockets, making our application super compatible. So that will be it for the first code. I'm going to just place these uh, comments at the right position so that anyone, if you want to access this code and try it out, you can understand it later. Then next is our configurer message broker. I'm going to be setting up two key prefixes here. First is going to be registry.enable simple broker, and I'm going to add /topic. This is the public channel. Anything sent to /topic will be broadcast from the server out to all subscribed clients. It's for server to client messaging, like sending an acknowledgement that a file was received, etc. So I'm going to be setting application destination prefixes with slash app. This is the client to server prefix. Any messaging coming from the client must start with slash app. It is a protected area where our controller mappings will live. It's like having a secure mailbox for clients to drop request and a public broadcaster system for server to reply. And let me put some comments over here. So for understanding purpose only, server to client messaging, as I said. And then finally, I'm using the configure WebSocket transport. Since we are dealing with potentially larger files, I am going to increase the message size and buffer limits a bit. So I'm going to type in registration dot set message. Okay, there happens to be an import error of some sort. Let me, okay. Okay, so I have added the same object and rename the reference over here. So I'm going to set the size limit to 10 megabytes just to be safe. So we are going to be writing it as 10 into 1024 into 1024. Now, you don't really want your large file uploads to fail all because of a default small buffer setting. So I'm going to copy this line and again paste it. And this time I'm going to say set send time limit. And this will be set to, okay, let us copy one more thing since we have done the message size and we have not done the buffer yet. So I'm going to increase the buffer size limit to 10 MBs as well. And since this is going to be a time limit, so we are going to change it in the form of milliseconds. So let me give in 20,000. This is done. Then I'm going to add some simple Java classes for the purpose of data transfer. So I'm going to create these inside the DTOs. I'm going to create one class over here and I'm going to call it as file payload. Now, inside this file payload, actually, let us understand what the file payload is all about. So, the file payload is what the client sends. It has the file's name and the file's binary content, which we are sending as a base string, base 64 encoded string. So, we're going to add file payload and then also file ACK, which is the acknowledgement object. It's what we will send back to the client to confirm the upload status like received or empty reload, etc. So inside the file payload, as I said, there is going to be one file name of type string and also one string for base 64 because we are going to save the file as base 64. So this is done pretty much. We're going to add the rate data annotation so that Lombok takes care of all the setters and getters and constructors for us. And then I'm going to do the same thing for file acknowledgement. I'm going to add this status instead of yeah, base 64. I'm going to add a status, and also I'm going to annotate it with at the rate data annotation again. So this is pretty much done. Let's move out to the WebSocket controller. Now for the action, we need to create one file WebSocket controller. It's where the client's file payload hits our server. So we are going to annotate this controller with at the rate controller annotation. Okay. Also, I'm going to be annotating at that SL4J for some logging. Let us add some dependencies over here. First, I'm going to be adding simple messaging template, and then I'm going to be adding another dependency. Or maybe, okay, we need to actually use constructor injection over here for messaging template. So let's do that. Then client will actually send PDF to slash app slash upload. So let us create one mapping for that. So we are going to be creating a method, and this method will be of type public, but it will have a written type of file acknowledgement, and we're going to call it as handle upload, and it will accept a file payload, the DTO that we just created, and we are going to be mapping it with at the rate message mapping and slash upload. Since we set the application prefix to the prefix to slash app, the client is actually sending the file to full destination slash app slash upload, and the return value is automatically sent back to another destination, that is at the rate send to, and we are going to use slash topic slash files to save that. This means that as soon as the server processes the upload, it sends a file acknowledgement or file ACK back to anyone listening on the slash topic slash files channel. That's how we get a real time notification on the client. Now, inside the method, we pull out the file name and the base64 string from the payload. I've added some basic checks here. So if the base64 string is missing, we will log a warning and return the status of empty payload, because we need to handle those edge cases over here. So I'm going to just type in file name equal to upload underscore. So we are actually naming the PDF with the help of current time in milliseconds, and naming it like that. If base64 is equal to null, or base64 is blank, we are going to log one warning over here that upload failed and base64 payload is missing. This is also done. If everything looks good, we log the name of the file and the length of the base64 data, which is always good for debugging, like for time frames and all. There seems to be some kind of an import error over here. Let us, okay, this was actually a typo over here. I've fixed that. After this, we are going to be moving towards, okay, let me finish the log first. So we need the file name as well as the base64 and the length of it. So I'm going to be calling the length method over here. Okay, after this, the most critical part we need to talk about is that we need to decode the PDF, and we need to save this to our disk. So I'm going to be initializing a byte array, and I'm going to name it as data, and let us use the base64 utility class and call the method get decoder dot decode, and I'm going to pass the base64 object, oh sorry, the base64 string over here. This line will take the string and convert it back to the original binary data of the PDF file. Then we set up a path to ensure that the TMP directory actually exists. So I'm going to call it as output path is equal to paths dot get file name tmp comma file name, and we would finish the job by writing the data array to disk. So this is for making sure that tmp directory exists or tmp folder exists. And then after that I'm going to write files dot create directories and output path. There seems to be an exception over here, so we are going to be adding that to the method signature as well. Now what we need to do is we need to just return a new file acknowledgement, file ack, and going to pass the file name comma a message that will say received. Okay, I need to pass it in the quotes, so received. This is the object that will broadcast back to the client confirming that the job is done. So we are done with this controller over here. After this controller, let me actually I'm going to be adding this entire block inside a try catch block, and I'm going to just do some exception handling, some basic exception handling here. I'm not going to pass any specific exception. I'm going to just type in exception e. So if anything goes wrong, we will be knowing what actually happened. So I'm going to type in log dot error and error processing upload, and I'm going to print the error message as well. And we are going to return a new file acknowledgement, and this acknowledgement will be unknown to us. So we are going to pass unknown slash unknown comma error. Okay, so this looks pretty much good over here. Done we are done with this controller logic for now. Okay, there seems to be an error. I have missed one semicolon. I am adding it. Now this is error free and done. So inside the templates folder, I'm going to create one HTML file, and this HTML file I'm going to name it as index.html, and I have copied one code for the HTML, so I'm going to just paste it here. Okay. This is actually, you can customize this a lot. You can actually use any kind of HTML code that you want. And now I want to create one page controller over here. So just to round it out, we have a simple MVC controller over here. So I'm going to annotate it with @controller annotation. It just maps out to the root URL slash. Uh, this will be mapped to an HTML template named index. So this is where we would put our front-end JavaScript logic to actually connect to the slash WS endpoint and send the file. So as I said, the get mapping will only have a slash inside it, and we are going to return the index. Okay, all looks good over here. Now inside the temp folder, I see there are some files actually present. So I'm going to be deleting this entire folder once, and we will actually check out if the folder is getting created with the help of our logic or not. Since we uh, since we added the logic to actually create that directory. Let us see if that is happening or not. So I'm going to run it now, and the code is running and it has started on the port 8080. Now let me check it in the browser. So I just open my Brave browser and I'm going to open the localhost 8080 port. Also, I'm going to copy it and I'm going to create another browser, and I'll also paste this link over here to actually access multiple clients at the same time. So as you can see, this opened without any problems. Let me click on inspect element and let me go to console. Now, as you can see that I am getting the logs that WebSocket is opened. And if you also see at the sources, you see some web jars over here, which contain the sock.js and the STOMP WebSocket dependencies that we installed over here. And if you go to the network tab and reload the page, you see that there is one WebSocket connection that happened. So first frame was connect, then after it connected, there was one subscribe frame there. And in the initiator tab, you can see that initially our request was an HTTP request. Then after that, it got converted to the WebSocket. So the bidirectional flow was set up after the HTTP request. So let me just grab these browsers over here. And now what I'm going to do is I'm going to come back to console. I'm going to close this tab below, and let me just add one PDF from one browser. So for that, I'm going to just choose a file and choose this sample PDF, and I'm going to send this PDF. And as you can see, you get multiple frames. First is the send frame and then the message frame. And you also get the acknowledgement that we created. So the sample.pdf was the file name for that particular file, and the received status was also set by us. So it is perfectly giving us the acknowledgement. Now, why did you get the acknowledgement for even from the sending side? That is because all the clients that were registered to that particular topic will get the particular acknowledgement. So also, if you can see in the console, you see one base64 string over here. You can actually copy it and open it in the browser. So to recap, we used WebSockets for fast, real-time and bidirectional communication. We used STOMP to structure our messages, and we used base64 to safely transmit those binary files over a text-only channel. These tools work together to create a smooth and scalable messaging experience, whether you're building a chat app or you're developing a health platform or any system that needs bidirectional and reliable data exchange. If you found this helpful, give it a thumbs up and consider subscribing for more practical dev walkthroughs like this. If you have any questions or want to see this integrated into a full stack project, drop a comment below. I'd love to hear what you have to say and what you're building. Thanks for watching, and I'll see you in the next one.